Now we are going to the third property of Jacobi symbol, that is, whenever m congruence to n mod p, whenever m congruence to n mod p, then m by p equals n by p. M by p equals n by p, where p is an odd positive integer. So this is our next property. How to prove this one? We know that its proof is, suppose p has a prime factorization. If p is a positive odd integer, then if p has the prime factorization, product p equals product I ranges from 1 to 1, pi to the power ai, then we know that it is given, the condition is m congruence to n mod p. M congruence to n mod p means it is m congruence to n mod, what is p? We know that p has a prime factorization, so this product I ranges from 1 to 1, pi to the power ai. For all I, now, yes, for all I. Now what is pi and pg? We know that pi and pj, they are, pi and pj are prime numbers, so surely any two prime numbers are relatively prime. So pi and pj, pi and pj are relatively prime means they have GCD 1. So pi and pj are relatively primes to each other for all I differs from j. Agree? So by m congruence to n mod product I range from 1 to pi to the power a means, this implies since pi and pj are relatively prime, then it is m congruence to n mod pi to the power a. Okay. So why? Because all of these are relatively primes. Now m congruence n mod pi to the power a means, we know that it is m congruence, it is n mod p. Okay. Or sorry, not n mod p, n mod pi. M congruence to n mod pi. Enough. So m congruence to n mod pi, m congruence to n mod pi, that implies then we have, it is m by pi equals n by pi. Why? What is pi? Pi is an odd prime. Pi is an odd prime. Then by Legendre symbol, we know that m congruence to, we have a result of the Legendre symbol, that is when m congruence to n mod, whenever n congruence to n mod p, then m by p equals n by p. That's a product result. Okay. Since pi is an odd prime, then by the property of Legendre symbol, we know that m by pi equals n by p. So that means, so it is product I ranges from 1 to 1, m by pi all to the power ai is equals product I ranges from 1 to 1, n by pi all to the power a. Clear? Okay. What is product? That is, what about the term on left side? Which is nothing but m by p equals, what is the on right side? Which is nothing but n by p. So when m congruence to n mod p, whenever m congruence to n mod p, we know that then from here we can conclude that this m by p equals n by p. Okay, that is again depends upon the property of Legendre symbol. Clear? Okay. Now we are going to the another property. Next property, when p and q are odd prime integers, then a square n by p, a square n by p equals n by p, where a and p are relatively prime. Whenever a and p are relatively prime, then a square n by p equals n by p. How to prove this one? What is p? P is a positive odd integer. Then since we have a square n by p, we know that when m and or as p be a positive odd integer, now come to the proof. If p be a positive odd integer, we have mn by p equals, it is m by p into n by p. This is the first property of Jacobi's. Agree? So by using this property, what is a square n by p? A square n by p, where p be a positive odd integer, it is equals a square by p into n by p. Agree? By the first property of, or with the light of the first property of Jacobi's symbol. Enough. So it is nothing but a square by p means what is p? P has a, since p be a prime integer, sorry, positive odd integer, then p has this prime factorization. It is p equals product I ranges from 1 to 1 pi to the power a. So this a square by p is product I ranges from 1 to 1 a square by pi, a square by pi to the power a into n by p. N by p is product I ranges from 1 to 1. It is n by pi to the power a. Enough. But we know that what is a square by pi? What is pi? Here pi is a prime because it is a pi is a prime. That is due to the prime factorization of p. Since pi is a prime, then by Legendre symbol a square pi equals 1. Why? Because when p is a prime, then m square by p equals 1. So not such. So using that argument, since pi is a prime, a square by pi equals 1. A square by pi equals 1. So product I ranges from 1 to 1 to the power a, that's again 1 itself. So the first product is reduces to 1. What remains here? So that equals, because it is 1, because a square by pi is 1. So 1 to the power a, that is 1. So what remains? Product I ranges from 1 to 1. N by pi to the power a is remains. What is actually this one? This is by Jacobi's symbol, nothing but n by p. So when a and p are relatively prime, a square by p is nothing but, a square n by p is nothing but n by p. Agreed? So these are the fundamental properties or basic properties of this Jacobi's symbol. So Jacobi's symbol, that is, so all of this proof of Jacobi's symbol, that is again heavily depends upon the Legendre's symbol. We know that Legendre's symbol is completely multiplicative. On using that argument here, we prove m by p, n by p equals mn by p. Moreover, n by p into n by q is n by p q. And if when m complements n mod p, then m by p is n by p. As well as when a and p are relatively prime, then a square n by p is nothing but n by p. Agreed? Okay. Now, there's an important theorem. The theorem states that if p is an odd positive integer, p be not a prime, odd positive integer, if p is an odd positive integer, then the evaluation of minus 1 by p and 2 by p. So we can evaluate minus 1 by p and 2 by p as by Legendre's symbol. Here the evaluation is minus 1 by p equals minus 1 to the power p minus 1 by 2, and 2 by p equals minus 1 to the power this capital P square minus 1 by 8, where this p is an odd positive integer. But in Legendre's symbol, we evaluated this minus 1 by p and 2 by p, where minus 1 by p is minus 1 to the power p minus 1 by 2. Yes, which is that possible, that is 1 if it is 1 congruence, or p, say it is congruence of p congruence 1 mod 4, minus 1 if p congruence it is 3 mod 4, and so on. Okay, that is by Legendre's symbol. Here, come to the proof. The evaluation of minus 1 by p and 2 by p, where p is a positive odd integer. How to evaluate this one? Since p be an odd positive integer, surely this p has a prime factorization. So let p equals product I ranges from 1 to 1 pi to the power a. Suppose p1, p2, etc. pr. then the primes are need not be distinct. So this P is product I ranges from 1 to 1, Pi to the power, or simply suppose this P equals product I ranges from 1 to R only Pa, not necessarily distinct. Let P equals P1, P2, etc. First suppose this P equals P1, etc. So P equals product I ranges from 1 to R Pa. This can be rewritten as product I ranges from 1 to R. This Pa can be rewritten as 1 plus Pa minus 1. 1 plus Pa minus 1. Then what is product I ranges from 1 to R? 1 plus Pa minus 1. It is the first term is 1 plus, it is 1 plus x. Agreed. So 1 plus, come on, 1 is P1 minus 1. This is the first term, or sigma I ranges P1 minus 1 into P2 minus 1 into etc. PR minus 1. That is the first term. Okay. So it is 1 equals 1 plus sigma I ranges from 1 to R P1 minus 1, or Pa minus 1. Enough? Plus the second term is sigma over I differs from J. It is P1 minus 1, Pa minus 1 into Pa minus J. Pa minus 1 into Pj minus 1. Right? So here it is Pa can be rewritten as 1 plus Pa minus 1, and product I ranges from 1 to R. 1 plus Pa minus 1 is 1 plus, what is the next term? It is sigma Pa minus 1, that is P1 minus 1 into P2 minus 1, etc. Plus sigma I range differs from J. Pa minus 1 into Pj minus 1, taken 2 at a time, plus etc. Okay. Yes. But what is Pa? We know that Pa is an odd prime. Why? Because of Pa is nothing but that is involving the prime factorization of P. Since Pa is an odd prime, what is Pa minus 1? Pa minus 1 is even. So this is equals 1 plus sigma over I ranges from 1 to R Pa minus 1 into, since Pa minus 1 is even, then all the term after the second, all the term except the first and second is nothing but a multiple of 4. Agreed? Since Pa minus 1 is even, then all the term in this infinite series, or in this series, not infinite, in this series, except the first two are multiple of 4, or divisible by 4. Pa minus 1, this is a multiple of 2, this is again multiple of 2, since these are even numbers, so ultimately this is a multiple of 4. Similarly, all the other terms. Agree? So this can be rewritten as it is equals that means we are starting from P, so P congruence to 1 plus sigma I ranges from 1 to R Pa minus 1 mod 4. Agree? Why? Because all the term in this series except the first and 2 is nothing but multiple of 4 itself. Enough. So from here, there is P minus 1 is congruence to sigma I ranges from 1 to 1 Pa minus 1 mod 4. Pa minus 1 mod 4. So that means P minus 1 by 2. P minus 1 by 2 is congruence to sigma I ranges from 1 to R Pa minus 1 by 2 mod 2, because of the property of congruences. But what is minus 1 by P? Minus 1 by P is, since P is product I ranges from 1 to R Pi, it is product I ranges from 1 to R minus 1 by Pi. Why? Because P is P1, P2, P3, etc. Pr. Agree? So this is nothing but product I ranges from 1 to R minus 1 by Pa is a product I ranges from 1 to R minus 1 by Pa is nothing but it is product I ranges from 1 to R. What is minus 1 by Pa? That is by due to evaluation of minus 1 by P in Legendre's symbol, we know that for any prime P, minus 1 by p is minus 1 to the power p minus 1 by 2. Okay, so it is minus 1 by pi is minus 1 to the power pi minus 1 by 2. Why? Because of Legendre symbol. We know that minus 1 by p, when p is an order prime, it equals minus 1 to the power p minus 1 by 2. So product I ranges from 1 to r minus 1 to the power pi minus 1 by 2 is nothing but it is minus 1 to the power pi minus 1 by 2, or minus 1 to the power means p1 minus 1 by 2 into etc. into minus 1 to the power pr minus 1 by 2. That is nothing but equals minus 1 to the power sigma I ranges from 1 to r pi minus 1 by 2. Okay. So minus 1 to the power sigma I ranges from 1 to 1 pi minus 1 by 2. So what is each pi? So sigma or minus 1 to the power sigma I ranges from 1 to 1 pi minus 1 by 2 means it is minus 1 to the power sigma I ranges from 1 to 1 pi minus 1 by 2 mod 2. Okay. Why? So that is nothing but it is minus 1 to the power p minus 1 by 2 from here. Enough. So this is the evaluation of minus 1 by p, where p is a positive order integer. That is again heavily depends upon the evaluation of minus 1 by p, where p is an order prime according to the Legendre's symbol. Clear? Okay.